Welcome to the deep dive. Today we're taking a really close look, maybe laser focused, you could say, at the global laser plastic welding market. We've
Interesting.
got this detailed market reports for 2025, and our plan is basically to sift through it, pull out the really interesting bits about the tech and where it's heading without getting lost in the weeds.
Exactly. And laser plastic welding, it might sound a bit sci-fi, but it's very real. It's becoming, well, pretty essential in industry. Just think of it like a super precise way to fuse plastics. You use these focused light beams, almost like a tiny controlled lightsaber for plastic parts.
A lightsaber for plastics, I like that.
And yeah, it gets technical, but we'll keep it clear. No need for heavy jargon.
Good, because the first thing that jumped out at me was just the size of this market. It's not some small niche thing, is it? The report says for 2025, it's projected at, what, USD 1825.4 million globally.
That's right, a huge number.
Yeah.
It tells you this tech is already a major player in manufacturing. And it doesn't stop there. The report sees really significant growth coming. They reckon by 2033, the market could reach USD 403.80 million.
Wow, okay. So doing the math, that's a compound annual growth rate, a UJGR, about 8.0% between 2025 and 2033. That's pretty strong growth, almost accelerating, really.
It is. It indicates a really robust upward trend.
So what's pushing it? What's the main engine here?
Well, one of the big drivers the report mentions is the aerospace sector. Think about components in planes, spacecraft. They have to be incredibly reliable.
Absolutely critical.
Right, so they need super dependable welds in plastic parts.
Okay.
And laser welding gives you that precision, that strength. It's often, step up from older methods like moving from, I don't know, fancy glue to a microscopic perfect weld.
Yeah, that puts it in perspective. Flying thousands of feet up, you need the best possible join, right?
Exactly. No room for error.
Okay, so where is this happening, geographically speaking?
So in 2025, North America actually had the biggest slice of the pie, over 40%. That translates to USD 529.37 million.
40%, okay.
And their growth projection up to 2033 is around 6.5% CAGR.
Yeah.
Within that, the U.S. is obviously the main player, USD 417.67 million, growing at about 6.3%.
Makes sense.
But interestingly, the report flags Canada as the fastest grower in North America, 7.3% CAGR.
Oh, interesting. Maybe specific industries there.
Could be. Maybe certain high-tech manufacturing niches they're strong in.
So North America's the current champ. What about Europe?
Europe held a pretty big share too, over 30% in 2025. Market size was about USD 438.10 million. The report points to the UK as a leader over there,
Why the UK?
likely because of their strong base in advanced automotive and medical manufacturing, industries where that high-precision plastic welding is really taking off.
Gotcha. And I bet Asia Pacific is moving fast, right? Given all the manufacturing there.
Oh, absolutely.
Yeah.
Asia Pacific, it accounted for around 23% of the global revenue in 2025, market size, USD 675.40 million.
Still substantial.
Yeah, but here's the kicker. This region is forecast to have the highest growth rate
Right.
globally, a whopping 10.0% CAGR from 2025 to 2033.
10%. Okay, that's significant.
Huge. Within APAC, China's got the biggest share, about USD 283.67 million in 2025, growing at 9.5%. But look at India, predicted to grow even faster, an 11.9% CAGR.
Wow, India. Why so fast?
The report suggests it's largely driven by their booming automotive sector. Just think about the sheer demand for cars, manufacturing efficiency. Laser welding fits right in.
Right, rising middle class, more vehicles. Yeah, that tracks. Okay, so APAC, especially India, is the one to watch for growth. What about South America, Middle East, Africa?
Yeah, those regions have smaller shares currently, but they're definitely growing too. South America is projected at 8.5% CAGR. Brazil's the leader there. Middle East, similar growth at 8.6%. Think UAE, Saudi Arabia.
Okay.
Africa's growth is a bit more modest, around 4.3%. Nigeria is mentioned as the biggest market. It kind of suggests that as manufacturing ramps up generally in these places, they'll adopt more advanced tech like this.
So it really is spreading globally. Okay, let's shift gears a bit. How else does the report slice and dice this market, the different segments?
Sure. They break it down a few key ways. First, system outlook. So standalone systems, like a self-contained welding machine, they have the biggest share right now. They're versatile.
You can place them anywhere, basically.
Right. But the fastest growing type is integrated systems. These are designed to plug right into a bigger automated production line.
Ah, like a robotic arm doing the welding as part of a larger process?
Exactly. More efficient, seamless operation. Fits that whole automated factory trend.
Makes sense. What about the actual method they use for welding?
Good question. So quasi-simultaneous welding apparently holds the largest share. You can sort of picture it like tracing the weld line very, very quickly with the laser, makes strong, consistent joints.
Okay.
But the fastest growing method is simultaneous welding.
Yeah.
Think of that more like hitting the whole weld seam at once with the laser energy.
So faster, more uniform heat.
Pretty much. Uniform heat distribution and potentially quicker cycle times.
Interesting distinction, and I assume that the type of laser matters a lot too.
Oh, definitely. For laser type, diode lasers are the most common right now. They're relatively compact, pretty cost-effective, the workhorses, you could say.
Right.
But fiber lasers are the ones seeing the fastest growth. They offer better efficiency, more precision, really important for those demanding applications.
So diode is the standard, fiber is the up-and-comer.
Kind of like that, yeah. Think standard light bulb versus a really powerful, focused laser pointer. Fiber gives you more control.
Okay. And what exactly are they welding with these lasers? What are the applications?
So the biggest application segment is just called components, which is broad, I know. It basically covers all sorts of individual parts that need joining.
Makes sense. That's the core job.
But the films segment is growing fastest. Think lightweight plastic films used in cars, interior linings maybe, or in electronics like flexible circuits, packaging too.
Ah, okay. Thinner materials, basically.
Exactly, where lightweighting is key.
And finally, the big question. Which industries are using this the most? The end users.
Right now, the automotive sector is dominant. No surprise there, really. The sheer number of cars made, plus more and more plastic parts for weight-saving safety features. They need reliable, fast joining.
Yeah, automotive is always huge for manufacturing tech.
But the electrical and electronic sector is the fastest growing end user.
Ah, because things keep getting smaller.
Precisely. Miniaturization is the key driver. Tiny, complex devices need incredibly precise ways to join delicate plastic bits.
So across the board, this tech is becoming more crucial. Okay, let's talk dynamics. What's really pushing the market forward and what's maybe holding it back? Drivers and restraints?
Okay, drivers.
Yeah.
The report lists several. First, just ongoing improvements in the laser tech itself. Faster speeds, better energy efficiency, makes it more appealing.
Better tools, basically.
Right. Second, the huge growth in electric vehicle production. EVs use a lot of complex plastic parts, like for battery housings, thermal management systems, stuff that needs advanced welding.
The EV revolution is a direct driver here.
Definitely. Also, the expanding medical device sector. Think catheters, diagnostic tools, those lab-on-a-chip things. They need sterile, perfect welds on plastic parts.
High stakes there, too.
Absolutely. Then there's the broader trend of automation and Industry 4.0. Laser welding fits perfectly with automated production lines because it's precise and fast.
Right, it's robot-friendly.
And finally, consumer electronics. Devices getting smaller, more complex, needing tiny, precise plastic joints. The report even mentions a specific tech by Youngkui Mi for real-time laser beam shaping as an example of these advancements.
That's a lot pushing it forward. What about the brakes, the restraints?
Well, one key thing is that the process can be quite sensitive. Material thickness, how well parts are aligned, it needs really tight control. Small variations can mess up the weld.
So it requires precision setup.
Yes, and the other big one is cost. The initial investment for these laser welding systems can be pretty high. That can be a barrier, especially for smaller companies, SMEs.
Yeah, the upfront cost hurdle. Okay, those make sense. What about trends? What's emerging?
We touched on one already, the increasing use of fiber lasers. Better performance driving that.
Right.
Another big trend is integrating artificial intelligence, AI, and the Internet of Things, IoT, into these systems.
Ah, the smart factory stuff. How does that apply here?
Well, AI can analyze weld data on the fly, optimize the laser settings, even spot potential defects before they become problems.
Yeah.
And IoT lets you connect the machines, monitor them remotely, gather data for predictive maintenance, predict when a part might fail, makes the whole process smarter, more reliable.
Very Industry 4.0.
Exactly. And finally, just continued R&D investment, companies pouring money into making the lasers even better and finding new ways to use them.
So it's definitely a field that's not standing still. Now, this report, being from 2025, mentions something specific. Impact of Trump's Liberation Day tariffs. What did it say about how those trade policies affected things?
Yeah, that's an interesting wrinkle. The report indicates those tariffs, brought in around 2025, caused, pretty major disruptions. It talks about the 10% tariffs on allies, but much higher rates on others, like 46% on Vietnam, 34% on China, plus that universal 25% on steel, aluminum, auto parts.
Right, those are widespread.
And the report specifically calls out the electronics sector as being hit really hard, especially with the U.S.-China trade situation. Tariffs on some Chinese electronics apparently went as high as 145%, and then China hit back with its own duties and reactions.
Wow, 145%. That's basically shutting the door. What did that mean for electronics using laser welding?
Well, it points to specific tariffs, like 25% on semiconductors, 20% on lithium-ion batteries, maybe 10–15% on general consumer gadgets. The direct result,
Hmm.
higher prices for consumers, potentially less demand.
Yeah, that follows.
And subsectors like home automation, computer hardware, even medical devices felt the squeeze. Costs went up for imported components, supply chains got tangled.
So companies had to scramble.
Totally. They started looking hard at sourcing from other places. India, Mexico, Vietnam were mentioned. Some even had to redesign products to swap out parts that got hit with heavy tariffs.
A huge headache for manufacturers.
Massive. And the report makes the point that even if you sourced a component from, say, Malaysia, its subparts might still come from China, so you couldn't fully escape the impact.
A tangled web.
Exactly. U.S. electronics firms just saw their input costs shoot up. And in that kind of volatile situation, the report really stresses how vital market research became. Finding alternative suppliers, tracking cost changes, figuring out how demand was shifting.
You needed good intel to navigate it.
For sure. It even notes big names like Apple and Dell were speeding up plans to move more production out of China because of all this.
So a really significant real-world impact from trade policy on this tech market. Okay, shifting back to the industry itself, who are the main companies? What's the competitive scene like?
The report describes it as, well, competitive. You've got big global players and smaller regional specialists all in the mix. And they're all basically focused on innovation to get ahead.
What kind of strategies are they using?
Things like developing better laser tech, making their products stand out with unique features, forming partnerships, investing heavily in R&D, and trying to expand into new regions. Standard competitive stuff, but intense. It even mentions a couple of recent moves. Dobot upgrading its welding solution in late 2024 for better quality and speed.
Okay.
And Yaskawa teaming up more closely with Burler Welding around the same time, aiming for more like integrated welding packages for customers.
So constant jockeying for position through tech and partnerships. Any specific big names mentioned?
Yeah, it lists several key players. You've got giants like Trump PF from Germany.
A big name in lasers?
Right. Hans Laser from China, Emerson from the U.S., Nippon Avionics from Japan, quite a few others too. It's a global field.
Okay, good to know the main players. So just to wrap up the regional picture, we talked about the numbers earlier, but can you just quickly recap who's leading now and who's growing fastest?
Sure. So the report's clear. North America was the dominant market share leader in 2025. That's down to their strong industrial base, already using advanced tech.
Actually, the established leader.
But Asia-Pacific is flagged as the region with the highest growth potential, fastest CAGR, driven by rapid industrialization happening there, big investments in modern manufacturing.
So North America leads on size today, but keep your eye on Asia-Pacific for future growth.
That's the takeaway. Precisely.
Well, this has been really insightful. A proper deep dive into laser plastic welding. So to sum it up, it's a big market already, set for really strong growth. Technology advances are key. Demand from aerospace, auto, electronics is pushing it. North America is the current heavyweight, but Asia-Pacific is coming up fast. And yeah, global trade issues like those tariffs throw a real curveball that companies have to manage.
Absolutely. It paints a picture of a dynamic, evolving field. And maybe a final thought to leave you with. As this tech gets smarter with AI and IoT, and as companies wrestle with these shifting trade winds, how can the smaller guys, the SMEs, get over that initial cost barrier? How can they tap into this advanced tech to actually compete effectively?
That's a great question. How do they jump in?
Yeah, something with big implications for manufacturing everywhere.
Definitely food for thought. So if you, the listener, want to dig deeper into maybe a specific region or how AI is changing things or the long-term fallout from those tariffs, well, hopefully this deep dive gave you a solid starting point. Thanks for joining us.